Okay, now what you can see on the screen is just a typical starting point. And what is the typical starting point? Is the code base. So you can see this folder here. This folder is just the code base, that is going to be somewhere on the developer's laptop, right? So please follow me because it's going to be very granular, straight to the point. And if you have any question, please ask the question. Now, excuse me, as an engineer, you'll be given that task to deploy this application. The developer does not have any business deploying the application. He has written the application, he has tested, he has written his test script, and everything is fine. The way the developer is going to test this application, remember, the way he's going to test this application is going to sort of run this manually on the system and just, ensures that the application can start and it can run. Very important. It can start and it can run. Right? And irrespective of the language, Node Express, Java, Golang, any language you want to use, the developer has all of the syntaxes that would have been given to you to run, to build, package, and run the application. Right? Now, this application, if we need to run it manually, it's just we just need to type go run and points it to the Golang application itself. It's as simple as this. Now, what are we doing here? We are passing this application to run locally on our system. So it means if we should go to let me not close the tabs. So it means if we should go to our local browser and type localhost 8080, we'll be presented with just a very simple page. So, and of course, you can pass your name. We are good. You can just pass. By the time you pass anything, it will just, whatever it is that you pass here will also be displayed here. Simple, like there is no, like it's just a simple application, right? There's no other thing that this application does than this. So that is what this application does. So if we cancel it out, we can run it locally. And if I try to run it again right now, it won't run because nothing is listening on this port 8080, and that's because I've stopped it. Now, as a DevOps practitioner, you need to Dockerize this application. We have talked about Dockerization, right? Which is what we have here. So this is a Docker file, and it's a multi-build stage Docker application. Once we get to security, we'll talk about why we are making use of multi-stage. But pretty much, we have talked about this. We have talked about what needs to be done. Is there anybody here that does not understand a multi-stage Docker build? Is there anybody? So I can just quickly run through it again very fast. Is there anybody? Or we'll just move on.
I think we understand that concept.
Please just run through it again. Please run through it again.
Okay, all right. So please go and watch the video again so that you're going to understand what needs to be done. Now, I'm so sorry, guys. I'm having a very serious flu. Now, the normal Docker file to be able to build this application is what we have here. And it's just this simple. The first line is the from keyword. It's telling you that whatever it is that you're going to be doing subsequently, you need to start from somewhere. You need to start from an entry point. And because this is a Golang application, we can start from what we call a base image, which is what we are doing on this number 1. After you get a base image, right, you create a working directory. And within that working directory, you are doing 2 things. You are creating the working directory and you are going into that working directory. So it's more like saying you are typing mkdir app and you are doing a cd into that app. So that is what this and this are actually the same thing. They're actually related. So you are creating a folder and you are seeding into that folder. That is what this working directory means. So you are creating this inside the Docker image itself. Now, this is inside your Docker image. This is inside your Docker image. This copy command is now saying that I need to copy my modules and my dependencies as well into the Docker image. That is what this copy is doing. So it is copying from outside. What is it copying? It is copying the go.mode. It is copying it inside this present working directory, right? And you are now running the go mode download to be able to, based on what is here, it is downloading all of the modules that are needed. So if I should go and check this go mode, you can see the module go 1.9. So based on this 1.9, it would download all of the modules needed, and then you are copying the other go modules into this same present directory. So this is just all about copying your source code into the image, line 5, 7, and 9. While 11 is to now build the source code. Remember that you've copied everything into this present working directory. Then by the time you run go mode/main, is going to build all of this that you've copied. It is going to build it to an executable. So by the time it builds this into an executable, the only thing that this image would need to run as a container is just this executable. It doesn't need all of these things as well. Do you understand? So this is more like saying, so you have a box over here. So you have the dependencies, you have the source code, you have some other binaries and some other materials that are needed. By the time you run your go build, whatever it is, right, this is going to convert it to a single executable file. So this is what the container will need to run. The container does not need these other stuffs again. It doesn't need it. It doesn't need it at all. Do you understand? This is what the container needs, right? And that is what we have here. So you can see that the container, for the container to start, it is not making reference to the source code and all of these modules. It is only making reference to what has been built. By running this go build/main, it will build it and turn it to an executable. Am I making sense? So now, based on this Docker file that we have here, right? By the time we build this, the image is going to be too big. And that is why we now need to reduce it to a light version. So when we get to security, I'm going to sort of break down. Okay, well, let me just explain this here as well. Now, the difference between this and this is that we have now introduced what we call a multi-build stage. Here, we are saying from Golang this, and we've now introduced a keyword called as. By the time you have this as build stage, it means you are creating a stage. You are creating a stage automatically. And what that means is that by the time you introduce that as keyword, it means, let's say this is the original container. By the time you introduce that as keyword here, it means you have partitioned this into 2. So this as keyword is telling you that I need to partition my my build into two. So this half here is what we now have defined here, which I'm going to discuss. Now, you've created the first box. Inside that first box, you are creating the work directory / app. You are copying whatever it is, just the normal way that we have when we're creating a Docker file, right? We're now running a test file. Can anybody tell me the reason why we need to run a unit test on this application? Can anybody remind me, why do we need to run a unit test on this application? Very fast.
Basically to test the functionality of the application before the build of the image.
Good. Does anybody understand what he said?
Yeah.
If you understand what he said exactly, you can just give a thumbs up and then we'll just move ahead, because I really want everybody to follow this, like everybody is clear. You understand? So we have a go run test to be able to test the functionality, just like it said, right? And then the normal go run build that we are doing. Now, instead of us to now end here, we are now introducing a second stage. You can see this as. That's why I say that whenever you see as, it means we are introducing another box. So here, we have a second as here, which now means that we have introduced box 2, and this is box 1. Now, by the time you now do that, we now have another from keyword. This time around, we are making use of a distroless image, a distroless based image that is very lean, that doesn't have so many dependencies. In fact, it's just like a box. Just see it like an empty car that does not have a chair. It doesn't have the car seat. It doesn't have the interior. It's just a container. So what we just need is just to copy what we need into that car. So this is like the car, right? This is like the car, and that is what we're going to use, compared to this one that is more like a bus that has, that has all the baggages, all the luggages. It has like just so many things, that is actually making the entire car to be heavy. But right here, we have already copied what we need from this car. We have copied it out. We have not copied it to a distroless light image, right? That is why we're making use of this from gcr.io distroless. There are so many distroless images that you can use. You can use Alpine, you can use different base images, right? You can use Debian, you can use CentOS, and what have you. Now, as build release stage, so we have created another build, another stage here. We're now creating another working directory, just the same way you have on line 3. We're creating another working directory, and we're now saying that the only thing that we need, remember where we're coming from, where we said that what is needed here is just this build. It's just this guy here. We don't need any other thing. And that is what we are doing here. We're now saying copying from where? Copying from this build stage, which is what we have here. We are saying copy from here, excuse me, copy from here, just this executable that we built. So, meaning copy this guy, copy it into this place. You can see that these other stuff that we have here, the dependencies, the source code and all, we're not copying them, we're only copying this build guy. We're copying it here. And remember that this one, it has the car seats, it has so many things like that is actually making this image to be large. But here, this is just the only thing that we have. Only the executable file. That is just the only thing that we need here, right? So we're copying it into this stage, which you can see here. We're saying copy from this build stage. What are you copying? You're copying the main, and you're copying it to another folder inside this same stage. Call it main. You can call it anything. You can call it main 2. You can call it main 3. You can call it anything. But let us keep things simple. So you are copying this main from this first build step. You are copying it to this present step, and then you're exposing port 80 because, of course, from the web application, what we're exposing is port 8080, and you have to expose port 8080 here. User non-root. I'm going to explain this, and then your command. Are we good? Do you understand this now? The person that asked that I should go over it again. Do you understand? Excuse me. Is this fine now?
Yes, sir.
Okay. The person that asked the question is not even.
The man will kick you. But it's fine, sir.
Okay. All right. Now, we're going to talk about this number 25 when we start talking about best security practices. Okay, good. Now, so to build this, of course, we can build it manually, but we have gone past that. We need to build this in a CI tool, and the CI tool, that we discussed is called TeamCity. So let's go back to our TeamCity. So I think I have the TeamCity open here, and this was the project that we made use of. Remember that by the time you are in TeamCity, you just need to be familiar of two things. So I want to confuse yourself. The first is what we call a project, right? The first is what we call a project, which is what you can see up here. What is a project? A project is just a container. It's a case. It's a bucket. What else can I use? It's a bag, that contains what? It contains the templates. It contains the build configuration. It contains the source control. It contains the connections. So everything that you will need to build this application, right? You need to set it up under what we call a project. So the same way, if I need to build this guy, where I will come here and do a Docker build, I will tag it to something, and I will run it like this, right? The same way, I need to set up that configuration within the CI. So the CI is the continuous integration tool. And the CI/CD are two different things. There's the CI, which is responsible for what? Which is responsible for building the application. Remember what we wanted to do here, where we're building manually. So if I need to build this application here, I can just come here and do a go build and point it to webform.go this way. You can see it has built it for me. But I don't want to be building this manually, right? I don't want to be building this manually, which is what you can see here. You can see the webform.exe. You can see this is the what? An executable, which was what I was explaining here. So the same way I did this manually is the same way Docker is also going to, go build. You can see that the command I ran here is still the same thing as what we have here. So instead of building this manually, let us hand over all of the stress to a guy that is a professional in building the Docker image automatically. So that is what the CI tool does. Of course, we have several of them. We have Circle CI, we have Spinnaker, we have like so many of them. We have Jenkins. So you can make use of anything. You can make use of any of those tools, right? Can you make use of any of those tools? Now, projects, I've said, is a container that contains what? Your source control connections. your build configurations, and what have you. Now, this is an example because we're not going to go around to sort of like recreate this. I'll just walk us through since we've already done this before. This is just like a revision class. This is the container itself, right? Which is a project. So let us edit the project and see what is here. So you can see the project, it contains the VCS roots. What does VCS roots means? VCS roots is saying that how do you want to connect to your repository? Because obviously this is sitting in a repository somewhere, which is what we have here. I don't know if I'm connected. Let's see. Bitbuckets. Excuse me. Okay, let's go one step upward. Okay, develop branch. Good. So you can see, is this the file? Yeah. So you can see the project over here. It is sitting within a repository. Now, how will this professional guy, how will he gain access to our repository? That is where we now define the VCS roots, which is what you can see here. I've defined the VCS roots. And it is asking that which branch do you want me to build? I've told you that Mr. Man, help me build the develop branch, which is evidence here. You can see that what the branch we're talking about here is the develop branch, right? And of course, it will ask for authentication. You know, this is our email. This is the password. This password, like I said in our CI/CD class, is not the password you use to log on to your Bitbucket. It's just an access token that you need to create from Bitbucket. If you're using GitHub, you have to create the access token to authenticate against your repository. And of course, you can test the connection just to ensure that you are connected. So that is basically everything about VCS roots. Now, remember that this is still the what? The project, right? This is still the project. Inside this project is now where we'll now create the build steps. What are build steps? Build steps are the different commands that we run to build the application. So you can see create build configuration. So by the time you create a new build configuration, you now define all of the build steps. But because we've done this, I will just sort of edit what we have in the last, like what we did in the last class, in the last CI/CD class. On the left-hand side, what do you have? You have version control settings, you have build steps, you have triggers, and all of this cool stuff that you have here. Right. So let's go to build steps. Now, what does this build step do? What does it do? It's just a sequential command that you are informing this guy that for me to build this application that I just did here, run these commands in the sequential manner. It's as simple as that. Run it in a what? In a sequential manner. What is the first command here? If you need to create a build step, you can just click on add build step here. And based on what you want to do, you can, just click on it. For example, we're talking about Docker. By the time I click Docker here, it's going to create a new build step, and then I can, fill in all of these fields. The step name. This is just to sort of help me recognize what that step is going to do. Of course, if I should just type maybe build Golang app. What do I want to do? What is the Docker command? Build, not push, but I'm building, right? Docker source file is a file. It is not a file content, right? So if it's a file content, then it means you have to copy the Docker file that we have here. It's just a matter of copying all of these things here and pasting it here. If I need to inform TeamCity, this is how you should be able to build an image. But I won't do that. We're going to make use of file. I say, what is the path to file? Now, because you're already connected to the VCS, right? If you should click on this icon here, we can point to the Docker file, which in this case is the Docker file.lite that we're making use of. We can leave this blank. And of course, you can now define the image. You can now define the image name that you actually want to create here. So, because we are going to be pushing this image to a Docker repository, you need to name your image to mimic your Docker repository. This is an example of a Docker repository. You can see this is my Docker repository. Right? You can see that the prefix is usually my username or the prefix. So because I'm going to be pushing to this Docker repository, you would have to also mimic that. Right? What is the next thing? You can give it a name, maybe new excuse me, maybe new app, and maybe you can just target with something, the build counter this way, so that automatically by the time you are building this image, if you need to start building this image from the first level, it means the resultant image name will now be Babula05/new app :1.0. If you build this the second time, the image that will be pushed to this my repository is going to be Babula05/new app :2.0. That is what this build counter is doing. Of course, you can select some other ones, build number, VCS number, it can, like, there's so many parameters that you can actually make use of, right? Then you can leave the remaining stuff like this and then save. But because I have this already, I'll just cancel out and show you what we have here. You can see what I did here. Docker build, the same thing, Babula05. I named it daas.ng. We can even rename it to something else. Maybe we can rename it new Golang. Right? You can give this any name. You can give this any number. Maybe we should start our own from 50.0. So it's going to be counting like that. And you're good. So let's save this. Well, let me just copy this out first. So we'll save this. After building, what is the next thing I need to do? I need to push it to my my repository here. So I will edit this, and it's still the same way, it's still the same step that we have. What is the step name? Docker push. So this can actually be anything. Step ID will pick from the step name. And instead of selecting build, you are selecting push because you are pushing. What do you want to push? This same thing I will copy it and save. That is all. That is all that I need to do. So for now, let me disable this step and disable this build step as well. Okay. So once that is done, we need to now set a trigger, meaning this is the developer. The developer has made some modifications. Instead of typing this manually, it needs to build this automatically so that any changes it makes here, it will just chill, sip some coffee, and wait for this professional guy to build that image for him. So that at the end of the day, what the developer or what the DevOps person just wants is just to see that that image that we created is here. Are you guys with me? Are you guys getting it?
Yes, sir.
Yes, yes, sir.
So how do we now set that trigger? Remember, on your build project, not on the root project now. On your build project, there's what we call trigger here. What do you want to do? You want to trigger a build. It's just straightforward. You want to trigger a build after a VCS check-in is detected. Meaning, if I should make any updates here, right? I need this TeamCity to be able to build the image for me. Okay. All right. So how do we now create that trigger? Just click on add new trigger, then choose the kind of trigger, VCS trigger, schedule trigger, finish build trigger. The two common triggers are VCS and schedule trigger, but just choose VCS and save. By the time you save, you are good, right? So I've already created it here. It's just the same thing. So what that means is that if we should come here and make an update, let's say we made an update here, my compile states, and I save this. After saving it, VCS will not kick in until I do a git, until I push to the repository. So, of course, this is just a revision during our git class. So I just need to add everything. Git add all, git status. So you can see that these are the files that I modified. Then git commit. What is the message? We are trying to trigger this build. Okay, then I can push. So that would be git push. I'm pushing to my develop branch. Okay. So by the time this is pushed, because of that trigger that we set here, after maybe like a minute or two, by the time we come back to our project, excuse me, we should see something pop up here automatically, telling you that I have received a trigger. Something has been done on that branch. I need to start building, which is what is going to happen here. Right, so let us wait for a few seconds. I think the default wait time is, I think, 1 minute 30 seconds or 2 minutes thereabouts. So, so let us wait for it.
Sorry, while we wait.
Yeah.
Quick question. While we wait, so how about if this needs to be authorized first before the trigger kicks in?
Yeah, good. So that is where you have a PR, because on production, what I did here is, okay, you can see, okay, well, so before I answer your question, so you can see that this is building right now. You can see I didn't do anything. It kicked in almost immediately. Now, for your question, right, what I did here is actually wrong, right? I shouldn't be able to push directly to the develop branch. What I need to do is to raise a PR, sort of raise a PR, so that by the time I raise a pull request, meaning I want to pull these changes, I want to pull it into develop. I want to pull these changes, right? That's what PR means, pull request. I want to pull these new changes, I want to pull it into the develop branch. Now, by the time I do that, right, someone in my team, maybe my team lead or someone senior, would have to approve that PR. And what does approve means? Is checking the changes that I want to merge into develop. Is checking it to ensure that what I'm actually doing will not break whatever it is that is on the develop branch. He approves it. By the time he approves it, guess what will happen? This guy is going to kick in automatically. Do you understand? This will kick in automatically. Do you understand? Is that clear?
Yes, yes. So,
yeah,
sorry to also go back. So it means that even during is it possible that during the when you're setting the build steps, you
Yep.
can set the trigger to be on pull requests.
Exactly. Yes. Yes, you can. Perfect. Yeah, that was a perfect answer. So you can set the trigger to be on pull request. You can set the trigger to be on a particular branch. So let's say, for example, now I have a branch. I have this branch. Instead of develop, I have just my own personal branch. If I should push to this, right? TeamCity will not build it because TeamCity is only aware that these are the branches that I should build. I can only build on develop or master branch. Do you understand? So with that, it will not build. But if I need it to build, I can now go ahead and specify. So let me show you where to do that. Edit configuration. Regas. Let me see. Okay, it's not here. Let me see. It's on general settings. Nope. Edit. Yeah. So can you see? What can you see here?
Specification.
Good. So you need to now specify. Let's say the default branch is develop. And I need to add other branches. Let's say I now want to build my own personal branch. Right? I will add it here. I can add it here. Right? Press enter. Add other branches here. Press enter like that. So that if I make any if I make any push, it doesn't need a PR because this is just my own personal branch. It doesn't need a PR. Whatever it is I'm doing here is not affecting develop. Do you understand? Which it is still build. But best practice is saying that you should only don't always build short-lived branches. So short-lived branches are branches that are not part of your conventional branches within your organization. And what are the conventional branches? It's usually develop or master branch. Do you understand? Develop branch is the application deployment code that is currently on either your development space or your quality assurance space. That is what they are still testing. That is why it's called a develop branch. But after testing the application, they've tested the application and they are good. The next thing that needs to be done is to just deploy the application to production. That is why you now need to commit to what? The production, or some organization use master branch. So before you commit to the master branch, of course, it would have undergone, testing and what have you. You will now create a last PR to merge that to master branch. Do you understand? But all these short-lived branches, it is not usually best practice to, run your short-lived branches, within the same environment that you have your develop and the master branch. Because what will happen is that your agents, let's say you have limited agents, maybe 2 agents, and then you have been committing to your short-lived branches for a very long time. Meanwhile, if there is a develop VCS or there is a production VCS, your short-lived branches will queue all of those ones behind. And if there's an urgent change that needs to go to production, your short-lived branches would just be wasting everybody's time. That is why best practice is saying that all your short-lived branches, just run it on your box. But for develop, production, leave it on your CI. Do you understand? So let's go back. Do you guys understand? Do you guys understand the logic?
Yes, sir.
Okay, yeah, good. So let's see our image. Let's see if it got here successfully. I think we called it new goal, and so you can see it is here, right? So that is just a brief summary of what this guy does. It's simple. Like, don't complicate your life by saying that you want to go and start learning multiple CIs. Jenkins is still the same thing as Jenkins. I've used Jenkins a lot of times. I've used Circle CI, I've used Spinnaker. It's just the same thing. But truth be told, I find this TeamCity very straightforward. It does the job. Like, it does the job for me. So why would I now have to go and start using a tool because it's popular? I can just use a tool that does the job for me, and I'm good. I don't want to always complicate my life because I want to sort of use a tool that is popular. Yes, it's good to be able to use a tool that is popular, but if you have something that does the job, why not just go ahead and use what does the job? For me, TeamCity does the job, and I've never looked back. In fact, I use this on production. Like, this is what we use on production. Do you understand? Okay,
One
good.
question.
Now, so, okay,
One
question.
question before you move on. Thank you.
Please
Now,
ask.
okay, cool. Now, okay, for example, you're good at TeamCity. That's what you use. Or you go to an organization that uses another let's say Circle Jenkins,
Yep.
the popular
Yeah.
one. So
Mhm.
are you supposed to advise them that they should, switch to TeamCity, or you just decide to use the one you're using? Just go ahead and use it, or you have to conform with what they use in the organization.
Okay, first things first. Company
Please, before you
policy.
answer that, let me
Okay,
also
all
add
right.
this. So
All right,
you
please.
now go for an interview, you are skilled in TeamCity. Now you
Yeah.
now go for an interview and they are talking about GitHub Actions.
Okay.
And you are skilled in TeamCity or you are skilled in Jenkins.
Yep.
How do you navigate those environments?
Good. Fantastic question. Okay, so let me start with Bamidele. Now, so for your own question, right? Company policy. Company has different policies. You can go to an organization and they're saying that based on our compliance measures and all, this is what you should use. You won't say because I know TeamCity, I won't use it, right? But what I would also advise is that by the time you get to a new organization, try as much as possible. You already have, like, you already know TeamCity, you already know some other tools as well. Just try as much as possible to settle in first. Understand what it is they are doing, how are they doing it, right? And then bring out all of the limitations that they have. For example, if they are struggling with whatever tool that they are using, and you feel that, man, TeamCity can actually do this better, you can just set up a POC. Set up a POC, discuss with your head, right? Discuss with your head, set up a POC, and sort of create the same, have a mirror project of what you have on that platform that you met in that new organization. Have a mirror, create it on TeamCity, set up a POC, invite your colleagues, run them through the advantages of using TeamCity, because TeamCity is actually open source, right? Run them through the advantage, and from there, they will be able to sort of, oh, okay, fine, this is nice. We can now do sort of migrate our project to TeamCity, or prioritize projects that are, prioritize important projects on TeamCity, while you leave other projects on, on the tool that they're actually making use of before. And before you know, they will gradually migrate to TeamCity. Now, let me tell you something. When I joined my present organization, right, they were using, I can't remember the tool that they were using, one code line, 142 like that. When I got in, I'm like, man, we can't scale with this because all of the subsidiaries were using the same instance. So the first thing I did was to run a POC, right? Because TeamCity was very, very easy. I ran a POC. I showed the dev guys, they were pleased, and that was how we started using TeamCity today. But if your company policy is saying that you must stick to Spinnaker, I know a very big organization today, in Lagos, where they stick to Spinnaker. Like, that is what they are sticking to. Nobody else can bring any others from outside. So that's part of company policy. Do you understand? But if you feel that, well, their tool is doing well, maybe they're using Jenkins and they're doing well, it's fine. Because of the knowledge that you already have, I can bet you can use the same knowledge on Jenkins as well. Just know that you have agents. You are going to create your build steps. We're going to create VCS. We're going to authenticate. That is all. Like there's no other, big deal there, unless maybe you now need to start learning some other advanced stuff. But it's still the same knowledge as needed. Do you understand? Bamdele, does that help?
Yeah, perfect answer. Thank you.
Yeah. So for the second question, right? So you're talking about GitHub Actions, how will you navigate or during an interview? I've conducted several interviews for the present organization as well, that I work for, as well as, I also consult for some other organizations where if they need a DevOps resource, sometimes they invite me for their panel interview and all. There has not been any time where someone comes in and say that I make use of GitHub Actions, but I don't know Jenkins. Then because of that, we are going to fail him. No. The only time we can fail that candidate is when we're asking him common CI/CD question and he doesn't answer. Then because he doesn't know the concept behind setting up a pipeline, then definitely he's going to struggle when it comes to other pipelines itself. So if you attend an interview and they're asking you questions about GitHub Actions, you can just tell them that, well, I heard about GitHub Actions before. I've not used it. But based on my knowledge on this, and this, I don't think it will be very difficult for me to navigate through GitHub Actions. It's as straightforward as that. Then they can now start asking you then a very important or a very intelligent recruiter can now start asking you questions along CI/CD. You will not start asking you questions along GitHub Actions itself because you've already told him that, okay, I don't know how to use GitHub Actions, but because of my knowledge in this, and this, I should be able to navigate through GitHub Actions in no time. Then I say, okay, fine. Then what are agents? How do you create VCS routes? How do you authenticate? And what have you? Do you understand? Unless that recruiter does not like you and say that, okay, because you don't know GitHub Actions, you know Jenkins, you know Circle CI, you know this, you know GitLab, right? But because you don't know GitHub Actions, then I'm going to fail you unless that recruiter doesn't just like you. Do you understand? But all interviews I've attended, interviews that I've been in, my discussion, like discussions with my colleagues, in the community I am, there's nobody that will tell you that you must know a particular CI tool. Like that, if you don't know that CI tool, right, you won't be able to get that job. Of course, the popular is Jenkins, and it's important for everybody to know at least barest minimum, know how to make use of Jenkins. Like very simple, straightforward. In addition to that, add another tool to it. It could be TeamCity, it could be GitLab, it could be Circle CI. Just play around with it. This is Circle CI, still the same logic. Circle CI, still the same logic. I want to see if they have. I want to see if they have a diagram. Let me see, pricing, cloud server. See. Just I can bet you the same thing, like the same. Let me see, cloud. Right, where they have a run up to 30 jobs at a time, choose rights. It's just basically the same thing. 5 active users. You can see 5 active users, 30,000 free credits per month. What else do they have here? I want to see where they have jobs. So you can see the number of concurrent jobs that can run at the same time. And just get started for free. You can get started for free because they have to authenticate, sign up. I don't want to go into that. But I'm telling you that if we should sign up together, right now, we can be able to build a pipeline as well in the next 5 minutes. It's the same thing. Spinnaker. This is another open source. Multi-cloud continuous delivery for enterprise. Though I've not used this before, but I'm sure that it's going to be the same process. Let me check their docs. Excuse me. Check their docs and see. So come like InterSwitch, they make use of Spinnaker. I know some of the guys there, set up a Spinnaker. Install it. These are the instructions. They're even telling you the server. Imagine to install Highland. They're just telling you, just play around, install. I don't know what this is. Choose a cloud provider, choose an environment, deploy Spinnaker. So that's just it. So that's just the simple GitLab as well. GitLab CI. Excuse me. Same logic as well. Getting started. But one thing with GitLab is they have a UI, so you can actually make use of the UI, or you make use of their own YAML syntax. So that's the beautiful thing about GitLab. So instead of making use of the UI as you are doing, you cannot define everything within a YAML code, which of course you have to learn, and not difficult as well. So this is like their own syntax, view. This is like their own syntax. So all your build steps are defined as a code. Okay, so you can see they call them stages. Stages, build, test, deploy. So this is just like what we have here. So this is just like what we have. Sorry, back to the project. So this is just like what we have here. Build steps. So instead of doing this way, you are defining your own in stages, which is even quite easy. So this is like the workflow. This is the name. So this name here is like the name of what you have here, Docker build. And then you can now, build your stuff and all. So that's that. Does that answer? Are you clear?
Yes, thanks.
Okay. All right. So moving on. So we'll move very fast now. So let's go to remember that we've pushed this now to what? We've pushed this to our GitHub. Next thing is, this thing is just sitting here. We have done half of the job. We have only done CI. We have not done CD. Right. So the CD tool to make use of when you want to deploy to your target environment, right? You can actually make use of what? Of OctopusDeploy. Same way, I worked with OctopusDeploy and I see it very interesting, and it does the job as well. Excuse me. It does the job as well. The same way with Jenkins, Spinnaker, same way. I love this tool very well. And of course, it's now very, very popular around. So it's now very, very popular, and it does the job as well. So a very quick revision of when we did the OctopusDeploy class, right? So we started by saying that the infrastructure for OctopusDeploy is quite similar to TeamCity, but they are different. So CI, which is for TeamCity, it only builds the application and then it pushes to an artifact repository, it pushes to whatever repository that you have. Now, for OctopusDeploy picks that image and releases it to the target environment. So you need to be careful of the words you use. You won't say, I want to deploy to an environment. What does that mean? You won't say, I want to deploy to server. You need to use the right terminologies, especially when you are, in an interview session, so that at least you are giving the interviewer a mindset that I know what I'm doing, like I know what I'm saying. This tool, right, what it does is that it releases the application to the target environment. And the target environment in this case could be what? Kubernetes. It could be AWS, it could be Azure, it could be GCP, it could be anywhere. But don't say that you want to release to a server. Just say that you are releasing to a target environment. That is all. That is what this tool does. So it picks from here, it picks this, and it releases it to a target environment. In other words, it picks from here and it deploys this to a server somewhere. You can also put it that way. But professionally, the word is release to the target environment. Okay? Now, under OctopusDeploy, by the time you come under infrastructure, this forms like the pillar of anything that you are doing under OctopusDeploy. Now, there's something that we call a deployment target. So, what is a deployment target? A deployment target is just a server where you want to deploy to. And the server could be AWS, Azure, anywhere. That is why it's called a target, a deployment target. So by the time you now say that you want to deploy to a deployment target, you can see that the English is will not really go well. Or instead you say, I want to release to a deployment target, or you want to release to a target. It's as simple as that. So this is where you define your targets, right? There's something that we call environment. And an environment is just a logical grouping of deployment targets. How you group your deployment targets. And a common environment is what we have here, as you can see on the screen: development, staging, and production. Within your development environment, right, you can say that I need my deployment targets to be within the development. I need the second deployment target to be within staging. And I need another deployment target to be on production. Do you understand? So that is how you create an environment. Just a grouping. You can see that this is now grouped. This is now grouping my what? My deployment targets that I just showed you here. You can see that this is the deployment target. This environment is now grouping it so that OctopusDeploy will not be confused as to where to deploy to. Right? So again, an environment is a logical grouping of deployment targets in OctopusDeploy. Now, what are target roles? What are target roles? So let me show you what target roles do. So in Octopus, if you are able to understand deployment targets, environments, and target roles, you're not going to have any issue. So I've explained deployment target, I've explained environment. Now let us look at target roles. Now, if I need to create a deployment target, right? I just need to click on deployment targets and then add deployment targets. So it's now asking me, you can see that all of these things, they are just servers, deployment targets, Windows, Linux, Mac, Azure, AWS, Kubernetes cluster, offline, whatever it is that we have there. But because we want to deploy to a Kubernetes cluster, just click on Kubernetes cluster here. It will tell you that let us set up a Kubernetes cluster target. Now click on add. What is going to bring out for you? Because we have the display name. What is the name of what is the display name that you want this target to have? Let's say daas Kubernetes server, something like this. Environments. Where do I want to put this environment? Let's say I want to put it under staging. Now, look at target roles. Very important. What are target roles? Target roles allow you to group deployment targets based on their role in the application architecture. They allow you to group deployment targets. Now, what this means is that this deployment target that I want to create, I need it to only house web applications, or I need it to only house my database application. So I cannot create a role and say that this daas.dr Kubernetes cluster server that we are building, right? We need to create a role to say that you are only going to handle database workload. Excuse me. I will just click on add new role here. Right? If I need the same deployment target to also handle front-end application, I can add it here as well. Do you understand? Because within my cluster, I might only want to target my database workloads. With that, I can now look and say that, okay, which server is responsible for handling database workloads? Based on these target roles, it is going to be this daas.dr Kubernetes cluster automatically. So that is what target role does. So it allows you to group your deployment targets based on their roles in the application architecture. Am I making sense? Do you guys understand? Do you guys understand?
Yes, sir. With you, sir.
Yes. Okay. All right. So now, remember, we want to connect to an existing Kubernetes cluster, right? I created a GCE Kubernetes cluster here on Google Cloud. Very, very easy. In fact, I tell people that Kubernetes on Google Cloud is the simplest ever. So this is the free account. You can see they gave me $300, and I've been using this since when? I've been using it since last week, and I still have $299, because what I do is that by the time I create a cluster and I'm done, testing whatever it is I want to test, I will just delete it automatically. This is just for testing. This is just more like my sandbox. I'm not running any workload. It's just to test out some things. For example, where I work, right? We work with different banks, different fintechs, and we help them, to be able to deploy our switch processors on cloud, on their cloud environments. So most of those guys, they use different cloud environments, AWS, Azure, Google Cloud, and all of that. So if I need to test something, I'll just come here and test whatever it is I want to test. I think I also have AWS as well. So Kubernetes, I think I've deleted the one I was working with. Okay, let me sign in again. So you can see how it's very important for you to be versatile, so that you not just say that, oh, okay, because it's AWS, I can only work on AWS. You need to be versatile, right? So Kubernetes. This is taking on. Yeah, Elastic EKS, still another fantastic Kubernetes offering. So it's very simple to set up. Add a cluster, create cluster name, daas cluster, Kubernetes version. Of course, this is the latest version. Version which is the end of support on 2024. If you don't update whatever. So this is like the latest version, right? You want to scroll down cluster service role. So you need to create an IAM role. Okay, well, our AWS class is next week. So for those that do not understand IAM role, I'm sure that by next week you're going to, have like an understanding of what this does. So this is more like a role that gives that user the permission to administer this cluster. That is also what this guy does. So you need to create a role. I don't have one. So by the time you create that role, you can now you can leave this defaults, click on next, but it's telling me to create a role. Of course, once you get to the AWS class, I can still go over this again, but it's very simple. The same way on Azure Kubernetes, on Azure as well. So I've worked with all of these guys before. And I'm telling you categorically that they are just the same thing. So this is Azure. I'm logging into my account now on Azure. And just to show you a look and feel. So Azure Kubernetes service. Yeah, this guy. Same way, create a cluster. Create a Kubernetes cluster. To pop up now. And if you are very good with Terraform, you can actually use Terraform to create all of this as well. So you need to create this in a resource group. So a resource group is just a container that helps you to combine related services together. So for example, if you have a front end application that you are building, it means that your front end application, as well as all of those other stateful services like RabbitMQ, Redis, your APIs, they all need to sit within the same group. So for you to be able to make them to sit within the same container, you need to create what we call a resource group. I'm sure that Shane actually showed you how to do this. So you need to create a resource group here. Let's say front end. Okay, so that means that I don't have permission, which is fine. So by the time you click on OK here, it will create a Kubernetes cluster to be within the same resource group. Then Kubernetes name, you can call it daas cluster. Region, this is more like collection of your different data centers, one or more different data centers. And for you to be able to have a region, you need to have multiple availability zones. So multiple AZs, which is also known as availability zones, they sit within a particular region. So of course, you can choose your region, maybe the one that's closest to your customers, right? Availability zone, you can make use of it. Excuse me. You can make use of a different zone. That's for the pricing tier. Version. Remember when we were coming from AWS, it was telling us that the latest version to use is what 1.28. Here it's telling us 1.27. And of course, you can see the 1.28 here, which you can select. And this is still the same authentication. So the IAM role that was telling us to create there on Azure, it is called what? Authentication and authorization RBAC. Do you understand? Which you will have to create and then click on view and create. So I just have to take you guys through this journey that if you need to create your own Kubernetes cluster, it is as simple as ABC, irrespective of the cloud that you need to create it. Alibaba Cloud. Same way, Kubernetes cluster. This is another popular cloud that is gaining weight now in Asia. Same guy, they call their own what? ACK. Same thing, right? They need to log in, and you can also. So if your customer is using Alibaba Cloud, excuse me, what it does need to do is just register. It's still the same Kubernetes, whatever that you have here, and just spin it up and simple like that. So let's go back to our GCP. So GCP, so to create a new GCP, just click on create. Excuse me. In fact, you can even be creating it now, or maybe we can actually make this as your assignment, part of your assessment for the week. You have to create a Kubernetes cluster on GCP, right? And set up whatever it is that I want to set up. The name, you can give it any name. Region, just like I mentioned, right? Then click on next, networking. You can just leave this default. Now, there's something that we call private cluster. And there's something that we call public cluster. Very, very important. Very, very important. What is a private cluster? A private cluster is a cluster that secures all your Kubernetes control plane components. I want an example of control plane components. We talked about it last week. etcd, kube controller, your DNS, whatever. All of those stuffs, right, are your control plane components. And if anybody gets hold of your etcd, then you are good as done. So what you usually want to do is to select a private cluster, so that if you need to now administer your control plane, if you need to do kubectl, run your command, right, you will need to go through what we call a bastion host. Man, we've not started cloud, we've not started AWS, but let me just quickly explain what that means here. So if I set up a Kubernetes public cluster, this is my cluster, these are my control planes over here. These are my control planes. So this is my control plane. This is my worker node. And of course, within the worker node, we have kubelets that communicates to the control plane, to communicate to who? The kube scheduler, to be able to schedule ports and what have you. So it means I'm here. This is me here. And this AKS or Kubernetes cluster is somewhere in Canada. What I just need to do is to authenticate to this cluster. And from here in Nigeria, I can start typing my kubectl command, kubectl create, kubectl this, kubectl that, because this is the public Kubernetes cluster. But for security purpose, right, whenever you are creating your cluster, this is still in Canada, instead of connecting directly to your control plane, right, within the same data center or within the same cloud. Sorry, I don't know what's wrong with my mouse. Within the same VPC, let me say, I don't want to be tempted to start using terms on AWS since we've not entered AWS, but in AWS, that's what we call VPC, Virtual Private Cloud, right? VPC is just like the entire network that you have within the cloud. Now, you now set up what we call a bastion host. This is a bastion host here. A bastion host is just a server that is able to communicate, with this cluster directly. So that whenever you now want to administer or control this cluster, you are not connecting to this directly, but you are connecting through the bastion host. In fact, if you should try to communicate to the control plane from outside, it will not even go through. It will bounce you because it's a private cluster. So you need a bastion host, right, that can now tunnel into your cluster. And with that, you are good to go. But before you even connect to your Bastion hosts, part of the things that you need to connect to this server here, it could be an EC2 instance, is to make use of what we call a private key and a public key. So what that means is that you would have created your private key and the public key on your system, and then you will now have to copy your public key, inform this EC2 instance that, Mr. Man, this is my public key. Sorry, this is my public key. So whenever I am coming in, right, authenticate me against my public key. So what that means is that if there's a rogue user here, or an attacker, let me just put an X on his head, that now wants to also log in through the Bastion host, even if he gets access to this Bastion host, because I have already informed this Bastion host that the only authentication method that you should use to admit anybody into yourself is by use of a public and private key. Where does this guy want to get the public key to be able to authenticate? Unless if this guy's laptop is hacked. But anybody that is just coming in, right, does not even have the rights to authenticate against this Bastion host. So this scenario is what we call a private Kubernetes cluster. These are a common interview question that they ask. What is the difference between a private Kubernetes cluster and a public Kubernetes cluster? Right? Okay, someone is asking, sir, please, when they say Bastion as a jump server, what does it mean? You have already answered the question, Ada. So a Bastion is just a jump server. It's as simple as that. A Bastion is just a jump server that has access to the internet. And then from there, you can be able to make use of whatever it is that you want to do. So next week, don't worry, just prepare for our AWS class. It's going to be very interesting. Like, everything is going to be hands-on. We'll talk about the VPC, the different kind of gateways that we have. And I'm sure that by then you're going to understand, like, have a full grasp of what it is that we're talking about. Right? Ada, do you understand?
Yes, sir.
Okay, yeah, cool. So going back, I just wanted to sort of digress a little bit so that by the time you see this, you won't be confused as, okay, what is the private cluster? What is the public cluster? And all. Do you understand? So they say choose a private cluster to assign whatever. This isolates the cluster's workload from public network. You cannot change the setting after the cluster is created. So you need to properly architect your environment, because by the time you create this, you cannot go back. And then you now start talking about, the different IP ranges and what have you. So I will just cancel this out and stick to the cluster that I have. So what do I have here? I have what we call an overview that gives me an overview of the Kubernetes engine. It's just telling me, just giving me few information about the Google Cloud. Clusters, of course, I have just one cluster. Workloads are just your ports. You can see that there's no big deal. Remember that we talk about ports, we talk about services, talk about config maps and all of those things. All of those, your workloads will be seen here. And then teams, collaboration, if you want to give access for guys to be also connect to your cluster, applications, config map, and what have you, network service mesh. If time permits, we'll talk about service mesh as well. I'll just explain what this does. I think Bayo asked this question during the last class. So I'll just try to fast forward to see if I can just explain what this does. Okay, good. Now we have our cluster. We now need to we need this guy. Where is it? We need this guy to be able to connect to that cluster. Now, under the deployment targets, right, we now have to authenticate it. Now, what are we authenticating against? We are authenticating against what? Google Cloud. right? It's telling me that when running a compute, use this associated VM. Just click on no, because we are not running in a compute engine. So a compute engine is just a server. It's just a server. So we're not running our workload on a compute engine, right? It's now saying that select accounts. Now, what does this account? Please, guys, I need you guys to follow me carefully so that you don't get confused. It's now saying that I should select my Google account. Where do I need to create an account? Right? Where do I need to create an account? You will need to create an account on what is it called now? On OctopusDeploy, so that you will now make use of that account to authenticate against the Kubernetes cluster. It's as simple as that. So how do we create the account? It's very simple. We would have to go to infrastructure. Let me just open this in another tab. And then you see accounts here. So create a new account. So what kind of account do you want to create? The Google Client account. Right? Account name, daas GCP. Description, this account is for the daas mentees to authenticate against the Kubernetes cluster on Google Cloud. If I hear, please, is Octopus the only option? No, Octopus is not the only option. Just like I've said, Ada, there are different options that you have as well. I don't know, maybe you joined the class late, right? There are different options that you have. You can make use of Jenkins, you can make use of GitLab CI, you can make use of Spinnaker, Circle CI, you can make use of any other CD tools available out there. It's still the same logic. The same logic. You can see that when I was showing you how to create a cluster on those cloud, you can see that it's just straightforward, but they can, on AWS, they call their own what? They call their own Elastic Kubernetes service. Google call their own Google Kubernetes engine. On Azure, they call their own what? Azure Kubernetes service. Common three. What is common in all these three? Anybody hear me?
Kubernetes.
Good.
Kubernetes.
Kubernetes. So on Jenkins as well, they can have their own terminology. But the most important thing is that, number one, you must have to connect to your cluster. How do you connect to your cluster? You have to, there are different methods to be able to connect to your cluster. So let's say, for example, now, I need to create an account to connect to, let's say, an AWS cluster now, right? What do I need to do? I need to come back to account. Let me discard these changes. Add an account. You can see all of the options I have here. AWS, Google Cloud, Azure Container Registry. In fact, even if I have a private Kubernetes cluster that is on my environment, I can also create an SSH key pair or create a token as well. So let's say AWS, create an account on AWS. The name, the access key, the secret key. So how do you create all of those things on AWS? Load. That is usually under what? Under IAM. IAM. Excuse me. Okay. So under IAM, go to users. Sorry, let me just search it from here. Excuse me. Okay. Things on our policies. Let me see. Nope, not under policy. But let me just create a user and assign.
I think it's under user, then you can create a secret key for that.
Exactly, yeah.
It's under the user. Click it.
So under the user,
Yeah.
then you can come to
Just create
secret
access key.
credentials. Yep. Okay, yeah. So from here, then you can now, so based on this, is that telling you that based on what you want to create, like the access key that you want to create, do you want it to have access to your command line interface or your local code, or for whatever stuff that you want to make use of? Let's say is for the command line. Click on next. You have to accept the confirmation, and this is so you can give it a tag. Let's say for K8 Kubernetes, create access key. So you can see your access key and your secret access key. So based on this is what you're now going to command. Excuse me. Sorry. So this is what you have to command to make use of here if you need to authenticate against the Kubernetes on AWS, right? So let us discard this and check for Azure subscription as well. So for Azure subscription, you have different methods of authenticating against the against Azure itself, right? There's something that we call principal accounts. So a principal account is just like a user account that an application can actually make use of to authenticate. Do you understand? So for example, here now, I'm not going to create a user account because obviously this is a machine that actually wants to make use of. This is a machine, of course, in this case, OctopusDeploy, that want to authenticate against Azure, to gain access to the Azure Kubernetes service. Of course, you can also make use of management certificates and what have you. So for you to be able to create this, you have to enter, your tenant ID, your application ID, and all that is needed, as well as your subscription, Azure subscription here, right? So for here, we're actually going to be making use of GCP, right? So this is going to be just the K8 GCP cloud, right? So you can leave this, just you can really add an account description over here. Then the key file. So here they make use of what we call a key file, and a key file is just more like a service account as well. The same way we have service principal, the same way we have access tokens, on AWS, just like we saw here, right? It's the same way GCP has their own, called a service account, because a service account is typically in the form of a key file. Now, how do you create that as well? So for you to be able to create a key file to authenticate against GCP, you need to go back to your GCP and just type your IAM, right? IAM, and I think it's IAM and admin. Let me see. IAM and admin. Let me see this guy. So just wait for it. Okay. So on your left-hand side, you see what we call a service account here. So with this service account, you can now create a new service account, just like you have here, and give it a service account name. K8 service accounts. Then service account description, you can just leave it there, create and continue. Good. You now have a role. Good. Now, what is a role? Again, we've not entered cloud, but this is just a simple explanation of what a role is. So there's something that we call a user. We have a user, we have a group, and then we have a role. A user is just a user, just like you know. A user is just, you know, an identity on AWS, or on Azure, or on any of the cloud. Just an identity, a username and password. Sorry, a username. So let's say the identity here is Dapo.Babalola. So this is just a user. Dapo.Babalola is in the DevOps, let's say in the DevOps group. This is what a group does. Now, to now give Dapo.Babalola extra privileges to be able to do stuff, it needs to wear a hat. So you can just see this as a hat. Oh, sorry. I need to go beyond a normal user. I need to do some other admin activities, like maybe administering the cluster, you know, deleting stuff.
Privileges.
Privileges, exactly. So I need to wear an extra hat. So this extra hat that I'm wearing is a role. Do you understand? That is what, and there are different roles that we have, which was what I think I was trying. Let me just put it down here. Cancel, done. Okay. You can see the different roles that you have. These are like examples of, you know, different roles. You can also create your own role, which we are not going to do yet. Right. So let me say, so this is a role for what? For EC2, you know, like different roles that we can actually make use of. Well, so the same thing applies to GCP as well. So I need to give this guy an extra privilege to be able to do some other things. So that is what this role within Google Cloud is actually asking for. So select the role. Now, what role do I want to give it? Now, these are the different roles. I can also manage roles as well, but these are the currently used. So what kind of role? I need to give that guy the ability to administer the what? Kubernetes engine service. Click on it, click on continue. Then if I now want specific users, this is when I will now start entering the specific user. But of course, we're not going to do that right now. We're going to keep it simple, and then click on done. Now, by the time you click on done, question now is, where do I get this key file that OctopusDeploy is asking me for? Where do I get it from? Because it told me to upload something. Where do I get it from? Right. The key file is usually gotten from this new guy that I just created. Where's even the new guy I just created? I don't even know the name I gave it. Was it this one I just created? Or this one? I think it was this, right?
No,
I can't even remember the name.
I'm not sure that's it. Maybe it should
Uh,
be fresh.
okay, let me just go back. Service accounts. I can't even remember the name of the, but I know it's one of these. Okay, is this guy here? Is this middle guy? So I've created the service accounts. I have assigned a role to it. Then I need to now download the JSON interpretation of this role. So what I don't have to do is just to click on these 3 dots, and then I can click on manage keys. No, sorry. I think I've missed it. Click on let me see how to download this guy. 1 minute. Manage. Let me see, manage keys. Okay. So we can create a new key here. So by the time you come back, by the time you've created your service account, right? Because OctopusDeploy is asking for a JSON key, you click on these 3 dots and click on manage keys here, right? Then add a new key, create a new key here. You can see the JSON that we're looking for. So by the time you click on create, it has downloaded that key for us. You can see the key here that I downloaded. Let's even open it and see. So this is it open here. So it just contains the private key and some other details, right? So now after downloading it, we'll go back to our Octopus and then import that key. So import it and then click on the environment. Remember that we're running this on what? On staging environments, and click on save and test. So it's trying to verify that it can connect to GCP, which you can see here. It has connected successfully. After connecting, you will now go back to your deployment targets and then create a target. So add a deployment target, Kubernetes cluster, click on add, and give it a display name. Environment, staging. Remember the rows that we created out that time. Database rows, right? Authentication, Google Cloud accounts, select accounts. So this was the one that we just created, right? The cluster name is going to be the name of this cluster. So let us go back to our Kubernetes. Excuse me. Our Kubernetes cluster that we created. So this is the cluster name here. So this cluster name is what is going to sit here. Projects, very interesting. What does this project means? Now, because Google is very sensitive when it comes to security, they want you to also enter what we call a project, which is also called a project ID. Question now is, how do you get the project ID? The simple way to get the project ID here is to go back to your Google cluster, to your Google Kubernetes engine, and then connect to your cluster this way. It's telling you that that you need to connect to your Cloud Shell, whatever. I just click on OK. So this would, excuse me. So this would connect, run in Cloud Shell. Sorry. So this would run. This will connect you to like the back end of this particular Kubernetes cluster itself. Just the same way we have on AWS, we have its own shell as well. We have Cloud Shell as well. On Azure, they have their own Cloud Shell as well. On Google, this is your own Cloud Shell. So it's telling me that I should authorize to the Cloud Shell, right? And it's trying to authenticate me, and I'm in right now. How do we get this project, which is also called a project ID? How do we get it? Now, For you to be able to get it, you just need to type gcloud config get value. What do you want to get? You want to get the value of what? Projects. So by the time you run this, okay, sorry, I made a mistake here. So it should be get dash value. You can see that I'm not cramming all of these things, right? So gcloud, just like for AWS as well, if you need, if you need to, let's say you want to query objects in an S3 bucket, you have to start with AWS S3 bucket list, right? That is going to list out all the content of a particular bucket that you have. The same thing here as your gcloud is just Google Cloud. I want to get the config of projects. So gcloud is what? Google Cloud. Config get value for project, meaning I want to get the config for an object called project. So by the time you click on OK, it's going to tell you that the config value for the project ID, sorry, the project ID config value for my account is this clear safeguard. I don't know what this means though. So, but this is just what OctopusDeploy is asking you for. So by the time you copy that, go back to your OctopusDeploy and just enter it, right? Select cluster type, regional or zonal. You can also get that from here. I think I can take this down. You can also get that from your overview. Cluster, and click on the cluster itself. Scroll down, you can see the name. Location type is what? Regional. Region, US Central 1. So because this is going to be regional, you also have to inform OctopusDeploy that it is regional and not zonal. Kubernetes detail is asking for the Kubernetes namespace, worker pool. So you can just leave all of this as default, and then you save it. But I won't save it because we already have one here already that we're using, which is this target here. Right. Now, after you've done this, then you are good to go with authentication. So you can see that for the past almost 1 hour, we've just been talking about authentication, how to be able to, connect, because it is like that. Because if you don't get authentication right, anybody can actually, what is it called now? Anybody can hack your cluster if you don't get the authentication right. So next thing is we need to now go ahead and create what we call a project. So a project is just the steps that is going to be needed to release this image to the Kubernetes cluster. That is what we want to define within a project. So let's create a new project. Excuse me. So quickly, let us quickly create a new project. Let's add a project and call this Kubernetes new. Let's call it daas Kubernetes deployment. Am I making sense so far?
Yes, very
Yes,
well.
you are.
Not.
Okay. All right. So create the project name this way. And you can see the beauty with OctopusDeploy is that it just wants to assist you. Like, it wants to make everything to be simple. It's telling you that how do you intend to use this project? What type of application you want to deploy? It will guide you through, but we don't want that. We just say, thank you, sir. We don't need your assistance right now. So skip, and then we have to create the process. So again, what is the process? The process is just the same way we have build steps here. The same way we also have processes as well. So just see these are like the different processes needed to deploy our app on the Kubernetes cluster. So let's create a process. So please follow me. carefully. Follow me carefully. Tell me that. What type of step do you want to add? What type of step? Meaning, what is the first thing that you want to do? I'm not telling you that, okay, I don't want to run a script, I don't want to run a package. Well, Google Cloud, I'm connecting to Google Cloud, but let's be more specific. I'm connecting to a Kubernetes cluster. So click on Kubernetes. It has now come up with a template to say that I can assist you to deploy your app. Just select any templates that you want here, and I will assist you with that. These are different templates. There's customize, there's deploy Kubernetes containers. You can run CLI scripts, you can run raw YAML, Helm charts. There's a lot to still talk about. I would have also wanted to take you guys on how to be able to make use of Helm charts, but time will not permit us in this bootcamp because Kubernetes is another wide topic on its own. So we're just going to keep things simple. We just want to deploy containers. This is our image. Remember, this is our image just sleeping. It is not doing anything. So let us activate it by deploying that image as a container. So let us add. Good. It is telling us that the step name deploy Kubernetes cluster. We leave it this way. So just leave all this default this way. Worker pool is telling you that within OctopusDeploy, who should be responsible for helping you to run your pool. You can just leave it default like this, right? Then now the target roles. Remember when we created our target roles here? Excuse me. Let me discard the changes. Excuse me, please. So remember that we created a target role when we were creating our deployment targets. Who can remind me of what a target role is, so that at least I will just have that assurance that we are all following? Who can remind me of what a target role is? Again.
So for me, I believe it's just like a segment to differentiate the type of application you are deploying.
Good, good. Do we all agree with Inka? Do we all agree? I don't need you guys to get it confused, so that you can see that we're just doing this thing like one step at a time. It's telling me that select your target roles. You know, it's saying that target roles are used as tag to select deployment, whatever, which is fine, which is what Inka has told us. So just click on this drop down and select the target role, which is what we have here as well. Web GKE. Right. So let's move on. Container image, just leave it as default. It runs directly on a worker. Just leave it as default this way. Now, so leave all this default this way. You don't need to tamper with this. We're not connecting to AWS. We're not connecting to Azure. Right. We are good with what we have. We already selected this and we are fine. Now, the next thing is to create a deployment, right? And remember that during our Kubernetes class, we say a deployment would help us to create pods, right? It's still the same thing. So let us now edit the YAML. It has predefined, it has given us a YAML file already, which we don't need. So we'll now go back to that our class on Kubernetes. You can see where all of the pieces are now coming together. So we can now go back to our Kubernetes class. I think I have it somewhere saved. Yes, you know, where we run our deployments, where we run our service. Is there anybody here that does not understand what this means? Before we start going further. Do we all understand this YAML file? Do we understand this YAML file?
Yes, we do.
Yes.
Okay, so we can proceed, right? We can proceed with this YAML file.
Yes.
Okay, good. Now, this YAML file, of course, is a deployment file that creates what? It creates a pod. And containers So let me just do a little. So this is a deployment file. Inside the deployment file, we have what we call replica sets. Inside the replica set, we have what we call the pod. Inside the pod, we now have what we call the container. So this is the what? Deployment. This is the what? Replica set. This is the what? A pod. And this is the what? A container. So a confusing question I'm going to ask in the interview is that what is the smallest object in a Kubernetes cluster? Everybody will say container, container, container. Wrong. The smallest object in a Kubernetes cluster is a what? A pod. Do you understand? That is the smallest. Forget that container sits inside a pod, but this is the smallest object in a Kubernetes cluster. So there was this time I was interviewing someone, for an advanced role, and inside the CV, he said he has deployed Kubernetes in this, he has done this, like during the interview, he was just telling, like he was just giving us all of the project that he has worked on. So sometimes, right, you might not be confused as to what should I even ask this guy based on what he has in his CV. This guy has over 4-5 years experience, right? We just ask him a question: what is the smallest unit? Sorry, what is the smallest object in a Kubernetes cluster? And the guy said container. Immediately, we knew that this guy. So it might not be technicality, but you need to go through documentation as well. This is very, very important. So there and then we knew that this guy was only good when it comes to hands-on, but in terms of having the actual understanding, right? He doesn't know it. Like he doesn't have the actual understanding of Kubernetes basics. Do you understand? So smallest object is not a container, it's a pod. So the file that will help us to create all of these things automatically is this file here, deployments. I think someone has a question. Did he get the job? Yes, he did. Ada. He actually got the job. So the fact that he missed that does not really mean that it's not good enough. Of course, he got the job. Okay. Yeah, cool. So this is the file that we need to create, and everybody understands it. This is just a container. So you can see the hierarchy. This is the what? This is the container. This is the pod definition. This is the what? Replica set. And this is the deployment. You can see how the hierarchy, moves up. Now, let's go ahead. What is the image name? The image that we created here, daas_new Golang, which is what we're going to define here. Daas_. Sorry, does anybody have any question? Is anybody talking? Okay. Okay, so daas_new Golang. The image ID here is not compulsory. It's not compulsory, but we can still add it. It's not compulsory, but we can still add it though. 5007. So I will show you why it's not compulsory, but let us add it. Then of course the container port is port. Excuse me. It's port 8080. So let's copy this and go and give it, because this guy is actually asking for food. So we'll give him the food needed, right? And then we'll click on next. Question now is, did we authenticate OctopusDeploy to be able to pull the image from my private repository? I think that's a question that someone should ask me, because when we're doing this, we only authenticated against Google Cloud. So how will OctopusDeploy pull or get this image from my registry? Because of course, I don't think this is actually private. Let me see. Is this a private repository? Let me just find out. Yes. Okay, sorry, it's public. So peradventure, this is private, right? I will have to create an account as well on OctopusDeploy to inform OctopusDeploy that if you want to pull images, this is the login credential that you use, to be able to pull images from this repository. But of course, because this is public, you might not really need that. But if it's private, I'll just show you how to do that very quickly. If it's private, what you just need to do is to go back to your Kubernetes, to your Octopus interface and click on library, right? Then click on external feeds, add feed. So you can give this, so you can select the name of the feed, which is what Docker container registry. You can give it the URL, credentials, username and password. You enter your username and password and you are good. So, but we won't do that now because we already have one here already set up. And that's what we're going to be using. Okay, now we have given this guy food. Click on next. It's telling me that this is just telling you what has changed, original and what has changed. Can you guys hear me?
Loud and clear.
Yes.
Okay, so just telling you what has changed and just confirm. Right, so we are good with that. So we are good with deployments. So let us go down and see what else they have. It's telling us that how many replicas do you want? So it's selecting one automatically because what we defined here was one. So it has extracted information and it's telling us that, okay, you want the replicas to be one. And the deployment name that you're giving it, which you can see here as well, is daas deployment, which is fine. It has extracted that. And there are some other labels. You can see app and daas. So it just extracted all the information. You can see the labels as well here. It has extracted it. It's just telling us, can we go on? Deployment strategy. Of course, I've explained the different types of deployment strategies we have. There's create deployment, rolling updates, blue, green. But the default that Kubernetes uses by default, but the default that Kubernetes uses is rolling updates, right? So you can still read more on this so that we don't take much of our time. It's telling us that just leave all these defaults, volumes, containers. It's telling us that this is where we're going to get our image from. This is where we're going to get our image from. They can leave all of these defaults and just so many things. If I want to start going into all of this, we won't leave here today. But let me just scroll down to see the important information that we have. Now, this is very important, pod security context. And that was why I said that I was going to come back to this image that we have, non-root. What does this mean? Now, anytime you see non-root, it means you are setting the user and group for this particular container to a non-privileged mode. Because if you should leave this as root, it means that if this container should get hacked, I'm repeating again for the third time. If this container should get hacked, because you're already running this container as root, the hacker can run root privileges, can run root command on your host directly, and your host will get destroyed. So it is very important that within your Docker file, you have this user non-root column non-root. This first one is user and this is root and this is group. User group, meaning I'm just creating a user called non-root to be in a group non-root, so that even if this container should get hijacked, right, you will not be able to do anything because of course you are not a root user. So because I have already specified this here, very important, so guys, because I've already specified this here. On Jenkins as well, or any other CD tool, you also come here and specify pod security context. You now say run as non-root. You now say enable run as non-root. But if you leave this way, if you leave it this way, right? Number one, your deployment will not even be successful because what you define here is to run as non-root, is to run as non-root, but here you are now disabling it. So you need to enable to run as non-root here, and it should be good. Then pod affinity, node affinity. This just has to do with if you have a particular worker node that you want maybe like your front end to run on. This is where you would define the pod affinity. So affinity is just saying that I have love for you. Like I have love for a particular person. For example, now I love football, right? I love football. Then it means that if you are grouping people around my environment, right, you can actually group them according to the love that they have for football. So it means I'm going to be part of that group because of the love I have for football. My wife does not like football. She's not a football person. She doesn't have any affinity for football. It means she's anti-affinity for football. But I have affinity for football. It means I'm going to be pulled towards people that have love for football. Do you understand? My wife loves what channel does she even watch? Netflix, Netflix movies, and all of that. I don't like I don't spend time watching movies like that, but she watches movies on Netflix. So she has affinity for Netflix. Me, I have anti-affinity. So by the time you understand that, you'll be able to put all of this into a better perspective. Pod affinity. So on a particular worker node now, you would have labeled that worker node to say that on this worker node, these are just the guys. So let's say, so these are different worker node. So on this worker node, these are just the guys that like football. These are the people that love Netflix. These are the people that enjoy maybe sleeping, right? So it means pod that have high love for football, right? They will be attached to this guy. Pods that have high love for Netflix, they'll be attached to this guy. This guy would never go to this guy because he doesn't have affinity for Netflix, which is me. And my wife can never come here because she doesn't like football. So you can read more on this as well. You can read more on, pod affinity, node affinity, and what have you. But we are not doing that now. We'll just move on. Okay? So I think that is that for deployment. Now,
Can
this.
can I ask you a question, please?
Please go ahead.
So I saw one part of that the option down after that affinity. I'm showing toleration down.
Yes.
So I think so I did an interview, I think last week. They asked me what is taint and toleration in Kubernetes. It shocked me. I was just
Oh,
so I'm now seeing toleration here also.
yes. So good. Okay, so let me answer that. So taint. You can see taint as insecticide. Let me draw an insecticide this way. But it's a good thing, though. Like, don't be, how do I even put it now? Like, see it as a good phase of learning, right?
Yeah.
So don't be sad that you are not able to answer that, because if you should go for any other interview and ask you that what is taint and toleration, you will know. So see this. So see this insecticide, right? So just see this insecticide this way and see a node like this. By the time you hear taint, right, the next thing that should come to your mind is, you know, when you are fleeting your room, when you are trying to apply insecticide, what you are going to hear is this sound. So just see that thing as taint. It means here you don't want mosquitoes to land on this guy. So you have already tainted it. So inside this worker node, there, like, you would definitely perceive insecticide. Mosquito will never land on this thing. It means pods that does not have toleration for this worker node will never land on this worker node. But even after tainting, pod that you have also identified that tolerates the insecticide that has been applied on this worker node anyways, tolerate it, then it means that the pod can still land on it successfully. Now, the use case is that if you have several worker nodes, and on this worker node A, worker node B, worker node C, you want only the front end pod to only land on this guy or on worker node A and worker node B. So in that case, you can apply what we call a toleration. So you are going to define the toleration within your deployment file to say that this front-end pod can land on C, they can land on A, they can land on B. But if you have a back-end pod that does not have any toleration configuration, right? The scheduler will never schedule it on this guy because it has been tainted. And these two back-end guys cannot land on this guy because they've been tainted and they don't have toleration configuration. But they can land on A, they can land on B. So taints would prevent ports that does not have toleration on, like, taint is going to prevent the port from being scheduled on that particular worker node. While toleration would allow that pod to land on worker node, you know, that's been tainted with that configuration itself. Do you understand what I'm trying to say? You understand the explanation, right?
Yes, but in a simpler form, can it be more like segmentation with tags? So if you have these
Yes.
particular tags, you can use this worker node. If you don't have these tags, you cannot.
Exactly.
Okay.
Exactly.
Okay.
That's perfect. But you
Yeah.
need to explain it in terms of taints and toleration. So don't use the word tag.
Okay.
Or, okay, well, you can still make use of annotation tags. But if you need to explain this way, you have to explain it the way I just explained. Okay, all right. So that's toleration. Excuse me. Then the next thing is service. Very well, very quickly. So a service is just a Kubernetes object that allows traffic to get to the pod. I hope you all understand what a service is. Do we all understand what this does?
Yes.
Good. So this is just a cluster IP that would allow traffic to hit the target pod. But one quick question here is that, how will this service know that I am to direct traffic to this pod that we have here? Anybody? Anybody?
Need to make use of labels.
Good. To make use of labels. Is this Ada?
Fubi.
Okay, Fumi. Okay. Your voice is almost same thing. Good. It will make use of labels. Do you guys understand? Guys, we're not coming back to this again, no.
I was going to give the option of the ports, that it would connect because of the ports, but on the script, okay, I see the label tag, but there's nothing in front of the label. Like there's no description yet in front of label.
Excuse me, please.
Can I respond, please?
Yeah, please respond.
So it's going to make use of the selector, that selector configuration that we put in the service part.
Okay, but we have not defined it yet on this script. Like looking at this script, it has not been defined yet.
It's here.
But look at selector, then they put app, daas.
Okay.
Then daas, yeah.
Okay. Yes, I see it now.
Do you understand now?
Yes.
Good. So what this is doing is that we have already defined a service, right? Now, we are saying that direct all traffic that is hitting this service, direct it to a particular pod. But which pod? That is where this selector now comes into play. And you can see that this selector is the same thing as what we have under the metadata of the pod. Remember, this is container. The next one is pod. So we are saying that Mr. Selector, direct all traffic to any pod that has this definition, that has this key value, app, daas, which is what we have here.
So sorry, please. So if we can also say selector or label, is that right or wrong?
You are right. You are right. Selector is mostly used in conjunction with services, while labels is usually in conjunction with ports. So that is why they will tell you that selectors and labels, do you understand? They work hand in hand. Do you understand? Because this is actually a pod template. And so this is a pod, but within the pod, I don't have selector, I have labels. Within my service, I don't have labels, I have selectors. Do you understand? So selector is your husband, label is the wife. Let me go and look for my wife. Do you understand the concept?
Yes.
Good. So let's copy the service and define it here. So let's click on next, confirm. So cluster IP, of course, it has read the cluster IP and automatically it has seen the port and the target port. So target ports, of course, it has to be the ports that the container is exposed to. Target, meaning who are we targeting? You know, we are targeting the port. That is why we have target port. So by the time you hear target, that is the destination. And then the port, of course, is the port of the service. So you can actually keep them to be the same thing. All right. So ingress, we don't have any ingress here. We don't have any config map. Config map. Okay, don't worry, we'll still come back to config map. We don't have any config map, and we should be good. So let us save this and run our first Kubernetes job. So we have saved this, right? Next thing is to what? Release it. You can see there's nothing like deploy it here. We are releasing it. So create a release. Right? Creating a release is saying that the version is 001. We are good. Packages. Now, this is where your image comes into play. That was why I told you initially that you shouldn't bother with this tag, right? Because if you have several, let me go to the general tags. Sorry, general, yeah. So if you have several tags over here, right, you're going to see them here. So you can select the version that you want to select. Do you understand? But if you are going to do it, if you are going to run it on a CI/CD level, which we are going to do after now, right? We'll do a commit, and we're going to watch the deployment from TeamCity to OctopusDeploy to deploy, and then we'll just go and refresh our browser. That is like a complete flow. If you're going to do that, it means that OctopusDeploy is going to, because here now, we're not defining anything manually, right? TeamCity is going to trigger OctopusDeploy to say, Mr. OctopusDeploy, go and release this particular container on Kubernetes. Make use of the latest image. So it will always make use of the latest image for deployment. So let's just save this. Of course, we don't have any other one. That's why you can't see the different tags here. Then click on save.
So
Okay.
on a quick one, I didn't mean you want to roll back. So you can just come to OctopusDeploy and select previous image version,
Exactly.
right?
Exactly. Yeah. Yep. Good. So deploy to developments and it just deploy. So good. So let us now be watching our Kubernetes cluster. Let's go back to workloads. And right now we have only one deployment. So let's just keep refreshing. So as we are refreshing, we'll go back here and be checking the log. So at least you even see what is happening. You even see what is happening. So it's saying now that all packages have been acquired, meaning it has gone to what? To Docker registry to go and acquire all packages. It has acquired it. So we are watching. Okay. So it is telling us that calamari, whatever, you just wait for it. So as you are doing this, let us go and be refreshing our cluster to even see what is happening. Okay, it has not gotten here. Let's go back and still watch. Okay. So I think right now it has gotten to Google Cloud. So let's go back and excuse me, and refresh. You can see it has created, but it's still creating. You can see the name of the deployment, daas deployment, which was what we defined here. Right? Okay, so let us go back and see what is happening here. So it's still trying to, create, it's still trying to do some stuffs. So let us wait for it. Let's see the tax summary. So it's trying to create some stuffs for us. Okay. So let's go back here and refresh. We don't want to see any red. We don't want to see any red. So it does not have minimum availability. Let's still wait for it because I believe it's still doing its stuff. If it fails, we'll see the reason why it failed. Okay. Let's refresh. Let's see. So let's see what is container has run as non-root and image has non-numeric user. Cannot verify user is non-root. Okay, so this is our issue here, right? So this is our issue here. So let's go back. Definitely this might actually fail, but let's see. Let us wait for it to finish. Okay. Let's see if it's still doing any other thing here. So maybe we'll just cancel it and resolve the issue. So it's complaining that container has run as non-root, which is what we want, and image has a non-numeric user, non-root. Cannot verify user is non-root, meaning it cannot verify if that user is a non-root. So which we have to resolve now. I just want this guy to finish to see if it would finish, or we'll just stop it entirely. Okay, good. So it has stopped, and of course we know what the issue is. Because we know what the issue is. So it stopped at the point of doing the deployment, of course, because of that non-root issue that we're having. So let's go back to the process. But before that, let me refresh and delete this job. So let's go and resolve our issue to see. So let's go and resolve our issue to see why we're having that. I think non-root is under security, I guess. It is the YAML deployment hosts. Service, okay. Service account name, tolerations, okay. Support security. So do not enable run. Okay, let's see a special that applies to all. Okay, run as group ID, run as group ID. So let's do something. Let's specify non-roots here, because since what we have here, since what we have within Docker Lite is a user and group called non-root. So, excuse me. Yeah, run. So this is a group, and so let's save this and see if it would work. Okay, must be an integer. Okay, so let's see. More information. Okay, no, let us disable this for now and save. I don't know why it's complaining about that, but let us save and let's create the same release. Save this. So you can see that the version has changed to 002. So let's go back to our, okay, so it's gone. And let's run this again. Deploy. So let's wait for it. And we'll follow the logs as usual. So this time around, it should be faster because it would have cached the packages needed. You can see it's fast. So let's see. Excuse me. Okay, so let's refresh and see. Okay, so you can see it is now okay. But let us wait for Kubernetes to finish its work. Okay, good. So you can see how we resolve the issue. But of course, I just did that to allow us proceed. Of course, best practice, because right now we are running this guy as root, which is not, do you understand? Which is not best practice. Because if anybody should get hold of this container on GKE, on Google Kubernetes engine, we are done. So this is very, again, disclaimer, this should always be set to true, right? So this should always be set to true, and we're able to figure out, how to be able to get the FS group and incorporate it inside our Docker file here, right? So I didn't run this prior to the class. I just felt, well, we should be able to, get it on the call, but we need to set the FS group as well as the group ID, and then incorporate it into our Docker file here, so that when we create the image, right, all of these figures would have been baked into the image, and then OctopusDeploy will now say that, okay, yes, this guy has been enabled to run as non-root and will not have that issue, right? So good stuff. So this has been created. So let's click on the deployment and even see what we have. So this is on what? Google Kubernetes engine. Right, so let's see what we have. You can see our selector, Ada. You can see our selector, app daas. You can
Yes.
see the pod itself, right? You can see the pod, you can see the service. So let's do something, because we are usually very inquisitive. Let us go into our cluster backend and connect. Let us connect to our cluster backend. Let me reconnect to the cloud shell. Excuse me. So that at least backend, we can see what is happening on the shell itself. So let us wait for a few seconds. Okay, so I can just quickly create an alias so that I don't have to always type kubectl. So k get pods. Let's see what we have here. Authorize. Good. Can you see that what we have here is the same thing as where's our workload? So this is the deployment. It's the same thing as what we have here. Can you see it? So this and this are the same thing. So let's get our service, k gets SVC. So this was the cluster IP that we created. And we all know that cluster IP enables what? Inter-pod communication. That is from one port to be able to communicate with another port, which is this cluster IP. And this is the name that we created here, which is what we have here. Sorry, where is it? Can you see daas service cluster IP? Daas service cluster IP. Can you see daas service cluster IP? Right, and we have that. Now, how do we now view this application? All the things that we've been doing since morning, how do we now view this application to ensure that it is reachable, and to ensure that we can be able to browse it on the internet? Anybody? Can anybody assist?
I think we can copy this external IP for the load balancer. Not sure.
Where? Because here I can't see any load balancer.
I was seeing the cloud and the CLI before.
Okay, the CLI, okay. Here, right? Are you talking about this?
Yes.
Are you sure? Because this is for another workload.
Oh,
I think we can use the, can you go back to the, yes, we can use the endpoint, the cluster IP endpoints. No.
Okay, are you sure? So
No,
if
no,
this is
no, no.
cluster IP, remember that cluster IP is just within
No,
the
no.
Kubernetes cluster.
Sorry, no, we can't use that.
Oh yeah, guys, let us think. What can we use? Remember the class that we had. Remember the class that we had. How many types of services do we have? Revision time.
We have cluster IP, we have the node ports.
Mm-hmm.
We have three. I can't remember the third one.
Load
now.
balancer.
Load balancer.
Good.
Load balancer.
Load balancer. And now that we're on the cloud, right? We now need to expose our service to a load balancer. So how do you do that? Just come here, expose. So you can do it this way, or since we know that we are going to the cloud, why don't you just make use of a load balancer here automatically? Either ways, we can do that, but just for simplicity's sake. What is our target port?
8080.
Good, 8080. Service type is what?
Is load balancer.
Load balancer.
And then what? Expose. So just scroll down here and click on gateways and services to watch the new guy here create. So you just keep refreshing until he's now able to create a load balancer for us. So right now he's trying to create a load balancer. So just keep refreshing. Just keep refreshing. Keep refreshing. It takes time, maybe like a minute or two. Good. So it means if you now come back to the Cloud Shell and do your get SVC, can you see that we now have our load balancer here?
Mm-hmm.
Do you understand?
Yeah.
Good. So it means if we should now click this, right, it should be able to show us our application. So run Oladapo. Does it make sense?
Yes.
Yes, it does.
So I have a question.
Oh, yeah, ask a question.
You know, you expose the pod, that particular pod. That means you attach the load balancer to the pod. In a
Yep.
case of where you have like 4 pods with different application, maybe one front end, one back end. So are they still going to, you only expose pod. Now you want to, let's say this one is for front end, you expose it with a load balancer.
Yep.
And you want to expose the back end also. Are you going to now attach another load balancer? I'm just thinking, or the same load balancer, but on different ports.
Well, so for that, right, that's where we now start talking about ingresses.
Okay.
Ingresses. So, but just to make it simple, like we can just make use of this. So for your question, right, we need to make use of what we call ingresses. And what that means is that here, what we did was to make use of one load balance IP, and then we pointed it directly to our pod. But for ingresses, we're going to have the load balancer / the name of the service, which can be a pod, the IP address of the load balancer / the name of the service, which can be your back end, like that, so that you don't have to continue to create different load balance IP addresses, because the more load balance IPs that you have, the more the cost.
Yeah.
And on AWS, that's when you start making use of elastic IPs. And elastic IP is money.
Yes.
Literally, if you don't use it and it's just there, it will cost you a lot. Do you understand?
Mm-hmm.
Do you understand?
Yeah, I understand. Thank
Yeah.
you.
Is it possible we do this exposure through the manifest system that we are writing?
Yes. Of course. In fact, let's even do it. That will
Thank
even
you.
be another what is it called now for us? That would be another deployment for us. So let's go back to our cluster and workload. So let's delete this guy. Excuse me. So let's just wait for it to finish. Okay, so it's gone already. Now, let's do two things, right? Based on what you asked, for us to be able to do it via the manifest, and also to add a config map. Remember what a config map is, where how many time has gone. Remember what the config map is, you know, when we ran this particular application and the color was showing blue. So what if we want to change it to yellow? What if you want to change it to yellow? What if you want to change it to white and all of those things? So we can actually pass the config map inside the container, right? So let's also do that now. I think I have it somewhere here. So this is still the deployment, but I've passed in another parameter that it should pass the config map, which of course I've defined as what, color green, or let me say color, okay, well, we cannot leave it as green, which I define as color green. Then inside the container, we are passing a config map ref, meaning copy a config map from config map with the name daas color config. So this is what we're going to make use of, as well as what is suggested, So let us go and copy. We'll just ask Kubernetes load balancer YAML templates. Remember, I said that you should always make use of the what is it called now? Of the documentation. So it's still the same thing. We just need to change the type to what, load balancer. So I'll just copy this and come back here. Just change this to load balancer. Right. So it means we have how many information? We have 3 information that we have to make use of. Right. This, and this information. So let us go and create it. So let us go back to our OctopusDeploy and process. So let me show you another way so that we'll not be restricting ourselves to this kind of, you know, deploying containers as well. So let's add a new step. Excuse me. Let's add a new step. And I want to tell the new step that before creating the container, right, help us create config map and help us create our service. So let us quickly do that. So I have to add the step. I know this is slow. So, you know, this is what deploy Kubernetes containers, right? I'm not saying that before creating the container, I want to create my config map, I want to create my service, and then create the containers. How do we do that? It's still the same thing. Let us add another step. Then click on Kubernetes. And instead of running Kubernetes containers, we're going to run raw Kubernetes YAML, this guy here. So we'll just add it. And yep, so here we can say deploy services and config map. Right, so just leave the default like this. On behalf of what, you have to select the same target role, leave this default. Then it's telling me that where is the YAML source of what you want to run? Inline, meaning we want to paste it here. So we'll now come here, would copy the load balancer, this way, paste it here, and copy the config map as well, and paste it here, right? So let's scroll down and see what we need. I think we are good, so we'll save this. But we have an issue. I need to run this before running the Kubernetes container. How do I do that? I will now need to rearrange it. So there's these 3 icons here, the other steps. I need this to run first before the container. So click on done. So that is going to go up and the container is going to come down. So now let us now go and remember that we have now added our service here. So instead of the initial way that we added it here, you can click on configure features here and then remove service. We don't need service again because service has been catered here. We don't need config map. In fact, we don't even need ingress. We don't even need secrets. We don't need all of this, but let us leave secret there. We don't need config map. We don't need ingress, and just click on OK. So you can see that we now have a streamlined configuration. But for deployment, remember that we have made modifications to our deployments, for this stuff that we have here, our image. And the config map that we added. Please, can you help us upload this? But I'm sorry, I have to join the class there. I would like to go through. Okay, no problem for me. It's fine. Okay, so let's copy this and place it and click on next, confirm, and save. Okay, so after saving this, let's now release it. We'll now see it in action. First and foremost, have we deleted our deployment? Okay, we have deleted it. So, so let's click on save. Then deploy. Deploy. And let us now watch it in action. Tax log. So let's watch it in action. So you can see it's creating the first step. So it's done already. It's done with that first step. It has created what now? It has created the service and also created the config map. It's going to the second one. So let's watch this in action as well. It's done. So let's go back, refresh. Can you see? So let's click on the deployment. And you can see load balancer automatically. So by the time we click this, let's see what will happen. Okay, let's check what is happening. Maybe it has not finished creating gateways. Okay, so there's an issue here. You can see the one I just created for us. It means that we have made an error. You know, when we're creating the load balancer, we have made an error when we're creating a load balancer over here. So we can do two things. It's either we come back here to check where the issue is, right? Or we resolve the issue here automatically. Now, you can see that the load balancer created, but the pod is showing 0, meaning that it is not able to route traffic to that pod because it doesn't even know where the pod is. So two things that we can do is to click inside here, to click on it itself, and let's click on edit and scroll down and see where the issue might be. So the target port is port 8080, and the port here is showing port 80. So let's attempt to change this to 8080 and click on save. Okay, let's go back to our gateways. Let's refresh. Let's refresh again. It's still not picking it. So something is wrong somewhere for it not to be picking it. So what will happen is, let's do something. Let us delete this, because sometimes GCP can be fun. Let us delete this, right? And let us wait for it to finish deleting. Okay, while that is deleting, let's go back to our workload. Go back to our deployments. And I need this to delete. So let me just refresh this. Okay, let's just create the pod and manually expose it again and see 8080 and expose. Then let's go back to the gateway. Excuse me. And keep refreshing. So this time around, excuse me. So let us wait for it to finish. So at least we'll see where our mistake is and correct it. Good. So it has created right now. So it means if you should click on this, if everything goes well, we should have, yeah, so we should have our green guy here, because remember that we uploaded a config map to change the color to green. So that's why we can see green here. But that is not the issue that we have right now. The issue now is, why is it not accepting the load balancer that we created from the YAML file itself? So that's what we want to find out now. And a very good way to find out is by clicking on the service itself and editing it. Let's edit it and see what we have defined here. So this was their own definition, and this was our own definition. So you can see where the issue is coming from now. So they want us to change this guy back to port 80 and leave the target port as port 8080, meaning the service, the load balancer service is going to be listening on port 80 and is going to direct the traffic to port 8080. So that is what they have here. Can you see? Port 80 and port what? Port 8080. Are you guys with me? Or we are getting confused?
We are with you.
Yeah, with you.
Okay, so yeah. So what will now happen is that we'll leave this way and do one last deployment. But this time around, for the last deployment, we are now going to do it from commit itself. So let us make modification to our service to change it to port 80 from OctopusDeploy. We'll change it to we'll click on our processes. So you can see that it created a service first and then created the config map. So how can you view the config map on GCE? By the time you just scroll down, you see config here. sorry, no, not from there. Yeah, here, secret and config maps. So you can see the config map that we created. And what is the value? Green. I see that this was created successfully for us. Then, yep, I think that is that. Okay, so let's go and modify our service where we made a mistake. Let's go and modify our service. So source code. Yep. So we change this guy to 80. And we should save this. Now, after saving this, we don't want to be running this manually again. We now want to run it from commits. We now want to combine everything together. That is connecting OctopusDeploy to TeamCity, so that by the time this guy is done, it is handing over to OctopusDeploy to make the deployments. And that's where we're going to stop for today. Now, what is the linking bridge between TeamCity and OctopusDeploy? That linking bridge is called the API key. It's called the API key. So you need to create an API key from OctopusDeploy and then attach it to TeamCity. How do you create it? From your OctopusDeploy.
Sorry.
Okay, please. Yep.
Did you say API key or
Yes.
API key? Q.
API.
Okay, thanks.
API keys.
Yeah, I get that.
Yep.
Q.
Keys. Keys.
Okay, keys.
Yes. Keys. So the linking bridge is to generate an API key from here. How do you do that? You click on this icon here, go to my profile, then you see API keys over here. So click on API keys and create a new API key. So purpose, maybe for K8 class, generate a new one. By the time you generate a new key, please copy it, because once you close it, you will never see it again for life. Do you understand? So by the time you copy it, you will now go back to your OctopusDeploy. Sorry, your TeamCity. And then you're going to add 2 additional build steps. The first one is the OctopusDeploy create release. You know that when we're here, when we're on OctopusDeploy, we're creating releases ourselves manually, but we are not going to create release. We will tell TeamCity that, Mr. TeamCity, after you finish pushing this Docker image to the Docker Hub, please create a release automatically on OctopusDeploy. You now said, okay, thank you. So let me enable this build step and show you what I did there. So if you need to create your own release, just click on add build step here and scroll down. You see Octopus release. So by the time you click on this, it's going to take you to what you want to quickly look at now. So I will edit this. And what is the step name? So I want to create release. Octopus URL is, just click on dashboard. This is your Octopus URL. Copy this like this. You copy the URL, paste it here, paste your key here. Octopus version, you can just leave it default. Space name, if you're working with spaces, this is a space here. But if you're not working with spaces, you can just leave it default. Then projects, you now have to go and copy the project name. Remember the project name. So this project was the one that we're working on, right? So you copy the project name this way. This is the project name. Release number. So we can maintain what we created, you know, by just adding 50. So this can be anything. This will just enable you so that when you want to create a new release, right? The release number is going to be what you're going to be seeing here. The same way you have 003, 002. But us, we can decide to start our own from 50 dot something, right? So by the time you are done with that, just click on save. Right? Now, after you've created that release, the next bit is now to deploy. So deploy to Kubernetes. So we're going to add it as a step here. Let me just enable the build step. So, so to add that, it's going to be deploy release. So I'm going to add OctopusDeploy release, which is what you can see here. But we're not going to add it since we already have it here. We just edit it to see what we have here. So I'll just edit this bit here. And of course, the same information, Octopus URL, the API key, the project. So this is the project. Release number 50. Environments is what? Deployment, because that is what we have here. Environments. Where is developments? So inside developments, sorry. You can see developments. That is the environment, which is what is asking for here, developments. And save. Now, this is where all of our effort for the past, how many weeks? For the past maybe 6 to 7 weeks. This is where we now practicalize it by doing a commit. So we are committing, and we need to just ensure that our app is properly deployed and we're able to see it. So let's do this. So let's go back to our project and watch it in action. So we're here, we watch this in action. We are here as well. This is our project. We're not going to touch, we're not going to do anything manually. We'll just be watching it in action, right? So how many places are we watching? We're watching from the CI to GitHub. We want to see it create here and see it deploy here, and also check the workload that has deployed here. So let's do this. So let's go back to our guy here, and let's do as if we want to make a deployment. So my compile state file. So we have made an update here, and let us commit it. Git add, right? Git status. So we have modified this file, right? Git commit message is, this is to test the full pipeline to GKE. Okay, so we have made a commit now. So let's push. Good. So let us see it in action. CI/CD in action. So let's watch. I'm not doing anything manual, so that this is my mouse. So let's watch it. We have made a commit. So we expect our trigger to trigger this build and not to shame us. So let's wait for our trigger. Okay. Our trigger doesn't want to come up.
It's like over 1 minute.
Okay, yeah, good. Our trigger is doing its wonders now. Our trigger should not shame also. So it is pending. Okay, you can see it is running, right? So as it's running, let us be checking the logs because I'm a big fan of checking logs. Big fan. I really want to see what it's like. What are you doing? What is it that you are doing? I usually want to expand everywhere. Like, let me see what this guy is doing. Okay, so he's building the image right now. So he's on step what? Step 1 of 4. So he's trying to build the image. So he's trying to build the image. So from step 1, it will go to step 2 to push the image. So I think it's almost done building. Okay, it has entered step 2, which you can see here. So it's pushing. Okay. It's pushing right now. Let's expand it. So it has pushed. It is entering step 3 now. So let us go here and just watch it. So meaning it has entered step 3. It is trying to create the release automatically. You can see that we are not doing any manual push. It's trying to create the release automatically. So let us wait for it.
It has gone past Docker.
Yes. So it has sent to Docker Hub. So in fact, it's very fast. It has created the release, and let us wait for it here. So you can see it.
Yeah.
Can you guys see it?
So yes. Yeah.
So let us check the logs as well. So tax log. It has even done step 1. It's trying to go through to step 2 right now.
Can you go back to the TeamCity?
Okay, TeamCity. Okay. So TeamCity is done. No? You can see.
Okay.
TeamCity is
Yeah.
done. It has now handed
Finished.
over to OctopusDeploy to finish its work. So you can see the transitioning from CI to CD.
To see.
Good. So let us wait for this to finish. So we'll just wait for this to finish. If I had known, we would have even deleted this guy. We have even deleted what was there before. But it's fine. You don't have, okay, so let us wait for it. So we're already seeing some issue, but let us wait for it. So what are the issues? Oh, insufficient CPU. So this might be an issue because I'm wearing the free tier. So it's telling me that I don't have sufficient CPU.
If you delete the existing one, this.
Yes. So okay.
This engine.
Yeah. So let's cancel this guy. Okay. Well, yes. Yeah. So that's true. Let's delete it. Let's delete it. I think the job has even failed already. Okay. No, it's still there. So let's delete this Nginx. Fresh. Okay. So let's see. Yeah, good. So I think let's see OctopusDeploy.
Okay, it worked now.
Yeah, so let's just wait for this guy to finish. I'm actually running with the free tier. So that's why my resource is good. So it's finished. So congratulations to us. So let's see what we have. That's deployments. Let's scroll down and click here. So let us wait for the load balancer. Let's go and see if it's correct in terms of the load balancing itself. So I think we might be having an issue with defining external load balancers on GCE. Because when we define external load balancer, I just noticed that now on the call, when we define an external load balancer here, right, it's not mapping the ports to the external load balancer, which you can see here, 00. So I think, well, I will have to check the documentation to find out why we are having that issue though, right? But this is still the same thing that we have. So this is still the same, so this is the same thing that we have here, right? Port is 80, target port is 8080. Port is 80, target port is 8080, and everything is fine, right? So if we should delete this and then now create it manually, that is when it works, which is quite strange. Which of course, I don't think it's an issue unless we have to remove it in our pipeline. We have to remove the load balancer IP in our pipeline and just leave it as cluster IP. So let's delete this. Right, go back to the workloads. And let us wait for this to get deleted. Okay, so while it's getting deleted, we can also still do it manually again. Click on the manage pod and expose. So you can see it's still the same configuration, 80, 80, 80. And then by the time we expose this manually this way, and go back to the gateways, services, and ingresses, it will create and eventually map. Can you see that it has even mapped automatically with the same configuration that we created? So I think when I have to check the documentation for Google Kubernetes engine load balancer configuration, maybe they do not permit load balancer to be created within a pipeline. I'll have to find out. Unless you can see that it has mapped it now. Let's also check the same configuration. Edit. Can you see this? Can you see that this and what we have here is the same thing? But the way it is right now, it is not allowing you to define a load balancer, right, in your pipeline. So which is a new one that I've learned today. So let us now go to the overview and check it. So you can see. So that brings us to the end of the class. I hope it was interesting and not confusing. Did you get something?
Yeah, sure. Yeah, sure. The recording will be
yes.
much more appreciated. The last one too,
yeah.
that last revision class, the recording is not yet out.
Okay,
Yeah.
okay. I'll get it across then. I'll get it across then.
This one.
So I want to do something. Let me even change this to what color? Maybe pink and see.
That's manually.
Yeah, manually. I'm just goofing around. Let me see if that's changed to pink. I don't think it will change to pink. It's still on green. So if we need to change it to pink, it means we have to come back to our guy here. We have to come back to our processes. Come here. Then come to our source code here and change it to pink. So by the time we save this and we deploy, by the time we change this and we deploy, let's remove this load balancer here. That doesn't affect our workload, and then add a cluster IP instead. Cluster IP instead, because cluster IP is the default. Cluster IP and save this. Yeah. So once, let me even see if it has changed. Maybe it takes time. Nope, still on green. So anyways, so that's the end of the class, but I just wanted to even test out that pink color. And so this is fine this way. So let me make a final commit on this guy. Add, save. So git add, git commit, and git push. Okay. So go back to our Golang and wait for it. So this one was the one that we had just now. That's on the Docker repo. So this was the one we had. Okay, 508. So let's see if our triggered. Okay, so our trigger is in now. Let's see it in action for the very last time. So the build number should be build number 9. Okay, one in build queue. Okay, so 9 is running. So this should be faster because it had done something before, so it should be faster. So VCS routes, because this guy is cached, you should be able to go to step 2 immediately. Okay. Okay, so that's gone to 2. So that's gone to 2. At the end of the day, we should see a pink background. Okay, sorry, this is still on. This is still building. Okay, I think it's almost done. Okay, it has gone to 3. So it means if I should refresh, we should see 5009. Meaning step, can you see 5009 is fine. So let's quickly go back to our overview. So you can see it is deploying already. So okay. So let's see what is happening. Let's go back to our cloud and check our workloads. Refresh. Okay, I think something is still going to happen. So let's check the task log and see. So it has deployed the cluster IP, it has deployed the config map. So it's about to go to 2 right now. I think it's on 2 right now. And let's see where that takes us. So let's refresh this. Just to ensure that we don't have any error. Okay. So let us wait for this guy to finish. Good. Done. So let's go back to our Kubernetes cluster and refresh. No error. So let's check our config map.
Okay, since it's the same thing. Yeah, we didn't get it this time around.
Exactly. So you can see that it has changed to pink, meaning
Pink, yeah.
config map worked. So let us go back to our workload and check our service, just to ensure that we are good with our service as well. That it didn't affect. So you can see that this guy is back. It's not mapping the external load balancer again. So I think this is
0.
yes. So this is something that we need to take into consideration when we are doing our assignments, to always hit the external load balancer. I think I also have to take a look at that. Why during deployment the external load balancer, defaults to 0.
Because the CPs, maybe because they have their own load balancer.
Yes, I think so too. So we don't have to come here, click on the pod, and expose to our port 8080, expose it, then check our gateways as well. You can see that it has now mapped to 1.1. And let us wait for a few seconds for it to be fully mapped. If I've learned something today, I've actually learned the art of how Kubernetes, of how Google provisions their own load balancer, which is very interesting. By the time we click this, we should see a pink background. So of course, you not see it because the word itself is pink. Do you understand? So that's why the background is this way. All right, so that brings us to the end of the class.
Please, can you go back to the... Okay. I wanted to see that Octopus again. No. The Google.